Hi, my name is Dave. I just want to welcome you to Ladder Math. Today we're going to talk about the laws of exponents made easy. The same way that a ladder takes you from where you are to where you need to be, I intend to do just that using a series of techniques and steps to connect you from where you are in your understanding of the laws of exponents to where you need to be. And I promise at the end of the video, you're going to find it very easy to remember all the laws of exponents. Not only that, but also to recall them for the future. And you're going to enjoy the process as well. I titled this video, The Laws of Exponents Made Easy. Okay, so before we dive into the laws of exponents, I just want to help you understand a few things, okay? I'm going to write 2 plus 2 plus 2. And my question for you is, how many 2's do you see? Well, I'm sure that everybody will tell me that they see 3 2's. That is correct. 3 times 2. As you can see, this one is multiplication. And this guy right here, those guys right here are addition. Well, to make it simple, multiplication simplifies addition. It's simpler to write 3 times 2 than to write 2 plus 2 plus 2. It takes less time, it's more concise, more compact, more condensed. So multiplication simplifies addition. Now, suppose I write 2 times 2 times 2. And I'm going to ask you the same question. How many 2's do you see? Well, I'm sure that everybody will tell me again that they see 3 2's. But I'm wondering, is there an operation that can help me simplify multiplication? Yes, there is. It's called exponents or powers. So I'm going to write 2 to the power 3. The reason why I don't write 2 times 3 is because multiplication already simplifies addition. I need another operation to simplify multiplication. So 2 to the power 3 simply means 2 times 2 times 2. Let me say that again. 2 to the power 3 simply means 3 2's that I multiply together. 2 times 2 times 2. Alright, with that understanding of exponents simplifies multiplication, let's do a few exercises and before we continue, okay? What about if I were to write 3, hold on one second, 3 to the power 4? How would you expand that? You can pause the video and try, and then after that you can resume. Alright? Okay. Okay, so welcome back. I'm sure that if you followed what we, the example that we did before, you can expand that as 3 times 3 times 3 times 3. Alright, because it's 3 to the power 4, those are 4 3's that I multiply together. And then last example, what about if I were to write 5 to the power, let's say 3? Well, that will be 5 times 5 times 5. Okay, so remember again, multiplication simplifies addition. And remember that exponent simplifies multiplication. That's all you need to master the laws of exponents, okay? Now, let's go ahead and start with the laws of exponents. Okay, so the first law we're going to explore is a to the power m times a to the power n equals a to what power? Okay? The second law that we're going to explore is a to the power m over a to the power n equals a to what power? Okay? The third law we're going to consider is a to the power m and to the power n equals a to what power? And then we're going to go to a to the power 0 equals what? And last one, we're going to consider a to the power negative n equals what? All right, so now I want you to guess. Okay, guess what is a to the power m times a to the power n. What's your guess? Is it a to the power m plus n, a to the power m times n? And believe me, a lot of people have issues to remember which one is which. That's why you need this video. Okay, now before I start showing you the technique and the steps that will help you master the laws of exponents, let me ask you these questions. I'm sure that you or someone you know has been to driving school. So, when you started driving, did you start driving in the freeway or in the parking lot? Well, I'm sure that you will say that, hey, that's ridiculous. You started driving in the parking lot. That's right. It wasn't until you get a lot of practice that you move from the parking lot to the freeway, right? Okay, so that's exactly what we are going to do now. Okay, follow closely, please. So it's not easy to understand what a to the power m times a to the power n is. It's not easy, all right? So what I'm going to do, I'm going to try something that is easier. I'm going to, instead of using variables, I'm going to use numbers. So 2 will replace a, and then let's say 2 to the power 3 will replace m times 2, let's say to the power 2. As you can see, what I did here, simply I replace the variables by numbers because it's easier for people to grasp, to understand numbers instead of variables, okay? So 2 to the power 3 times 2 to the power 2, and I'm going to see what that gave me, okay? But you remember earlier I told you that exponent simplifies multiplication. So therefore, 2 to the power 3, I can expand it because it simply means 2 times 2 times 2. Okay? That's 2 to the power 3. Times, now 2 to the power 2 is 2 times 2. As you can see, I end up with, hold on one second, I end up with 2 times 2 times 2 times 2 times 2. Now let's see what that is. Since exponent simplifies multiplication, this gives me 2 to the power 1, 2, 3, 4, 5. 2 to the power 5. Now I go back to the original setting, 2 to the power 3 times 2 to the power 2. And I'm going to try to see what happened here. What did I do? Did I add them? Did I multiply the exponent? Did I subtract them? What did I do? Well, 3 plus 2 equals 5, so I realized that 2 to the power 3 times 2 to the power 2 equals 2. Hold on one second. Equals 2 to the power 3 plus 2. Voila. That's it. Congratulations, we just found the first laws of exponent. So if it works for numbers, that's right here. That's the parking lot. And then this one is the freeway. So when I had 2 to the power 3 times 2 to the power 2, it gave me 2 to the power 3 plus 2. So therefore, when I have a to the power m times a to the power n, it's going to give me a to the power, you guess it, m plus n. Alright? Now pause the video now and try a few examples on your own. Okay, now let's proceed to the next one. We have a to the power m over a to the power n, and we want to know what's the result. So a to what power? Again, that's the freeway, because understanding variables is difficult. So what I'm going to do, I'm going to use numbers to help me understand the variables, okay? How they behave, how they react to each other. So I'm going to say, instead of a to the power m, I'm going to say 2 to the power 5, for example, over 2 to the power 3. And then I'm going to try to see what that gives me. 2 to what power? 2 to the power 5 is, hold on 1 second, 2 to the power 5 is 2 times 2 times 2 times 2 times 2. Okay, that's 2 to the power 5. And 2 to the power 3 is 2 times 2 times 2. Well, as you can see, 2 divided by 2 equals 1. 2 divided by 2 equals 1. 2 divided by 2 equals 1. So therefore the result is 2 to the power 2. Now I go back to my original setting, and I'm going to see what I did here. Did I add the exponent? Did I multiply them? Did I subtract them in order to get that result? Well, 5 minus 3 equals 2, so therefore I subtract them. Right? It's 5 minus 3. Guess what? Congratulations again. We just found the second law of exponent. Okay? Which is a to the power m over a to the power n equals a to the power, you guess it, m minus n. Sorry for that, m minus n. Okay? Okay, now we can use those two formulas to find all the remaining laws. Believe it or not, it's going to be very easy and very straightforward. Okay, let's take this law, for example. A to the power m to the power n equals a to what power? Well, again, let's use numbers. Let's do 2 to the power 3 to the power 2 equals 2 to what power? Well, remember that exponent simplifies multiplication. So the 2 from the outside tells me that I take 2 to the power 3 and I multiply it by itself 2 times. So therefore, I'm just going to go ahead and write 2 to the power 3 times 2 to the power 3. And then, as you can recall, you remember this law right here. So I'm just going to add the exponents. So equals 2 to the power 6, because 3 plus 3 equals 6. Now I go back to see what I did here between 2 and 3 to get 6. Did I add them, multiply, subtract, divide? Well, you guess it, I multiply them. So therefore, it's going to be 2 to the power 3 times 2. Now I can make a general case. A to the power m times a to the power n equals a to the power m times n. Wow. Okay, next up. What about if we get a to the power 0 equals what? Okay, now let me ask you a question. In order to get 0, what about if I replace a to the power m minus n by a to the power m minus m? What do that give me? Well, m minus m equals 0. But you recall that when I had a to the power m times a to the power n, I could write it as a to the power m over a to the power n, right? So therefore, if I follow the same pattern, I can write a to the power m minus m as a to the power m over a to the power m. Now, because anything divided by itself equals 1, so I can conclude that a to the power 0, because m minus m equals 0, I can conclude that a to the power 0 equals 1. Done. Okay? And then last law that we're going to consider today is the following. Okay, now the last law we're going to talk about is what is a to the power negative n? What is that? Now I have a question for you. This law right here, it looks like this one, but it misses something. It misses something. Can you tell me what it is? Well, I'm sure that you tell me that it misses the m part, right? As you can see, a to the power m minus n, this one is simply a to the power negative n. Well, if I wanted to add something here that will not modify the value of the negative n, what should it be? Well, I'm sure that if you think a little bit about it, you can think of a number like a 0, a to the power 0 minus n, right? Because a to the power 0 minus n is still a to the power negative n. Well, if I have a to the power 0 minus n, I can follow the same pattern as above, right? To rewrite it as a to the power 0 over a to the power n. Okay? If you don't remember, please review the first part of the video, and then as you recall, a to the power 0 equals 1, so therefore a to the power negative n equals 1 over a to the power n. Well, ladies and gentlemen, this is, as you can see, we just found all the laws of exponents. Okay? All the laws of exponents. So if you have any questions, please leave me a comment, let me know. And if you like it, if it's helped you a little bit, I would appreciate it if you can share that with your friend who are struggling with the laws of exponent. Thank you. See you in the next video.